Hello geometry students, Mrs. Fallon here. Welcome back to another riveting geometry video. Today we are on lesson 7.3 on page 207 of your student journals. All right, so we're going to chat a little bit about some more theorems, right? So we haven't had enough theorems, we're going to learn some more. Actually, these are really similar to the ones we learned last video. And so basically what we're talking about here are the converses of all of the theorems that we learned the last time. So remember what a converse is. It's kind of like writing it in reverse, right? So it's the converse of that theorem. So the parallelogram opposite side converse. If both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. All right, so basically what we're getting at here, and for all of these theorems, these are theorems that we're going to use to help us prove whether a shape, a quadrilateral, is a parallelogram. And so one of the ways we can prove that a quadrilateral is a parallelogram is by showing that opposite sides are congruent. So if we can show that opposite sides are congruent, then we know by the parallel opposite sides converse theorem, then that shape has to be a parallelogram. And so basically that's kind of going to be our game plan. We're going to use this as kind of our one of the ways that we can prove that quadrilaterals are parallelograms. So same thing here, parallelogram opposite angles converse. So we know that opposite angles are congruent. So A is congruent to C, angle B is congruent to angle D. If we know those to be true, then we can say that that is a parallelogram. Again, another way for helping us prove whether or not something is a parallelogram. And then the last one here, or the next one I should say, is opposite sides parallel and congruent. So this one isn't a converse, this is actually a new one. So this is another way that we can prove something is a parallelogram. So rather than just kind of showing the properties in reverse, if we can show that we have one set of sides that is both congruent and parallel. So we have one set of sides that's both congruent and parallel. So we're talking about the same set of sides. If we can show that to be true, then this shape has to be a parallelogram. And then the last one that we're going to use to help us prove a shape is a parallelogram is the parallelogram diagonals converse. And so again, kind of like the opposite of what we talked about before, if the diagonals, remember the diagonals connect opposite vertices, so non-consecutive vertices. In other words, A connects to C and B connects to D. So in this quadrilateral, there are two diagonals. So if diagonal BD is congruent, or I'm sorry, if diagonal BD and AC bisect each other, then this has to be a parallelogram. So remember what it means to bisect each other. It means that this line segment is bisected, or in other words, cut into two congruent pieces. This line segment, BD, is cut into two congruent pieces. If we can show that all of those things, that this is congruent to this and this is congruent to that, then we can state that that is a parallelogram. So this chart on page 208 of your student journals is actually pretty helpful. So it's just the 5 ways in which we can prove a quadrilateral is a parallelogram. And the reason I'm pointing this out is because as we go through this and kind of do more proofs, and you're going to do some proofs on your own, you may want to refer back to this. So again, this is just kind of reiterating some of the things we've talked about before. So one of the ways we can show that a quadrilateral is a parallelogram is if we can show both pairs of opposite sides are parallel. So we're using the definition here. So this is, if you were going to use this, your rationale, your reason, and your proof would be by definition of parallelogram. So again, if you can show both two sets of parallel sides. And then this is the parallelogram opposite side converse. Opposite sides are congruent, therefore this must be a parallelogram. This is opposite angles converse. If opposite angles are congruent, then this must be a parallelogram. If a pair of opposite sides is both congruent and parallel, then it must be a parallelogram. And if the diagonals bisect each other, then it must be a parallelogram. So all of these right here, all 4 of these are all about different theorems. So all of these are there's 3 that are converse and 1 that's just kind of a normal. So those are the ones you kind of want to pay attention to. Like you wouldn't use a reasoning in your proof if you showed that like opposite sides are congruent, for example. You wouldn't say by definition of parallelogram. Your reasoning would have to be if you're showing that opposite sides are congruent and then stating that this is a parallelogram, then you would have to state the parallelogram opposite side converse. So you're going to want to pay attention to this page in particular. All right, I'm going to give you guys a second to kind of do this, but we're going to walk through a proof. So if you want to write this down on your paper, you can pause the video. I'm going to walk through this particular proof. So when you're ready, unpause and then join me back. All right, so this is kind of a standard proof that we're going to use. And so our given, so I just kind of drew a quadrilateral here. So we're given that AB is congruent to CD. So I'm going to mark that on my diagram. And we're given that BC is congruent to DA. So what we're trying to do here is we're trying to prove the opposite sides are congruent converse. So remember that theorem that we just talked about that said that if opposite sides of a quadrilateral are congruent, then we know that it has to be a parallelogram. So this is the proof for that theorem. All right, so we're going to start by kind of writing our given like we normally do. All right. All right, step 2. What I would like you to do here, and this is kind of a common one that we use. We did this before in the past with when we did triangle congruence. I want you to draw in a line segment. So I want you to draw in line segment A to C. So basically you're just drawing in that diagonal. And the reason why we can do this is by definition of a line, basically. A line, and I'm just going to write down kind of what it means. The line exists between any 2 points. So remember, that's kind of our like a definition of what we're getting at here. Okay, so once we know that, kind of our game plan here is to go back to what we talked about in the previous units, where we're basically proving triangles are congruent. So we know this side is congruent to this side, and this side is congruent, well, I'm sorry, those two sides are congruent, these two sides are congruent. So we are given that we have two sets of sides. So if you remember when we did triangle proofs, what we were looking for is that hidden information. And so our hidden information here is that AC is congruent to AC because of that's that reflexive property. So now if you take a look, do you realize how do we know that those two triangles are congruent? So our plan of our proof is to prove that these two triangles are congruent. And then we can show, then we're going to be able to show, hopefully, that we can have this as a parallelogram by definition. So again, we're proving one of the theorems. So the only thing we know here is the definition of a parallelogram. All right, so anyway, did you notice that we have side, side, side? So I'm going to say triangle ABC is congruent to triangle CDA. And my rationale is side, side, side. So the reason why that's important is now that we know these two triangles are congruent, we know all of their corresponding pieces are congruent. So again, if we're trying to prove this is a parallelogram, the only thing we can use right now, since we're trying to prove one of the theorems, is we can only use the definition. So by definition, we have to show that opposite sides are parallel. So in order for us to show opposite sides are parallel, what we want to do is we want to show that we have maybe some sets of alternate interior angles that are congruent so that we can show that those opposite sides are indeed parallel. So what it would look like is this. I'm going to show you that BAC, so angle BAC, is congruent to angle DCA. So BAC is right here, DCA is right here. So like angle 1 is congruent to angle 2. Notice that they're alternate interior angles. I also can say angle BCA is congruent to angle DAC. And so again, BCA, I'm going to call this 3, and then DAC is 4. So notice we have that set of alternate interior angles. So I'm going to say we know those are congruent by CPCTC. So the reason we know those are congruent is because if these triangles are congruent, then all of their pieces are congruent, which means all of their sides are congruent, all of their angles are congruent. All right, so now that we've shown that alternate interior angles are congruent, we can state that AB is parallel to CD, and we can state that BC is parallel to AD. And the reason we know that is that alternate interior angles converse. So alternate interior angles converse. And so if you remember, the converse basically says you can show that alternate interior angles are congruent, which is what we did up here in our proof. We showed that alternate interior angles are congruent. Then you know the lines have to be parallel. So that's what that converse is stating. All right, now that we've shown that opposite sides are parallel, well, we can state that ABCD, that's supposed to say ABCD, sorry about that, is a parallelogram. I always use my abbreviation for parallelogram because, well, I'm lazy and don't like to write as much. So why do we know that? By definition of parallelogram. Okay, that's the kind of proof. So this is the proof for the theorem that stated if opposite sides are congruent, then we have to know that this is a parallelogram. So we could do a similar proof for all of the other theorems we talked about. So like the opposite angles are congruent, then the quadrilateral is a parallelogram. We could do a very similar proof like we just did here for that particular theorem. Or we could do the one where if it's an opposite side is both congruent and parallel, then we know it's a parallelogram. So we can prove all of those theorems. And again, it's important that if you're proving a theorem, you have to only kind of use what you know. So like, for example, if we're proving a theorem, then we can't use the theorems themselves. So we have to use only the definition of what a parallelogram is, because that's the only kind of information that we know for a fact if we're trying to prove a theorem. All right, so I would encourage you to practice. So go back through. A lot of this is going to be you kind of reading through this, making sure you understand the theorems, and then go back through and try a couple stuff. So go on to big ideas, try some of the homework, some of the practice, try some of the proofs especially. You're always welcome to kind of try an additional proof on, on your own, and you're welcome to kind of bring it to class and we can kind of look over it. But again, you're going to want to try some of these things using those theorems that we just talked about. All right, good luck. If you have any questions, bring them to class. Bye for now.